children of YouTube. I, student 2.
And I am student 4.
We'll be discussing one of our first physics videos on energy. Now, what is energy? Energy is the ability of an object to do work. Now, in physics, work has a very specific meaning. Work is the energy transferred to an object by an applied force over measured displacement. Now, what the heck does that mean? I'll give you an example. Take this chair, for example. All right? I'm going to apply energy to it. Now I've done work to it. Now, the force I've applied to it and the displacement from start to finish, multiplying those, is work. Student 4, could you please explain the equation of work?
Well, as we all know, work is defined by the amount of force applied, the applied force. This is key, not net force, nothing else, just applied force, multiplied by the total displacement. If you don't know what displacement is, it's simple. It's not distance, it's just how far has it changed in position.
From start to finish, right?
Yes. So let's say you could run in a circle and end where you started. You have displaced 0 meters.
And therefore, you're useless because you've done zero work. Zero displacement, zero work.
Well, I wouldn't say useless, student 2. Remember, be positive.
Right.
So, we in the equation is basically work equals FD. Force is obviously F, displacement is obviously D. The units in SI are newtons for force, named after Isaac Newton, the famous guy we all know and love, with the apples. And we have
love.
Meters for displacement. Meters, not feet, inches. No, we use metric here. So, FD. What is our F? 20 newtons applied to this chair. What is our D?
1 meter.
Exactly.
So, how much work have we done to it?
Well, let's just multiply them together.
Awesome.
20
62.
times 1. 42, no. 20 joules.
What's a joule?
Well, a joule is the SI, or Système International, unit for energy. And it simply is named after the famous scientist James Prescott Joule. We all love him. He did a bunch of stuff for us. Yeah, now student 2's brains are all over the carpet. Could we get some cleanup in aisle 2?
Okay, now, work can be positive, negative, zero, or cyclical. Don't worry about cyclical yet, we'll get to that. Positive work is when the force and the displacement are in the same direction. For example, I'm pushing student 4. Direction and the force I applied were in the same direction.
No, it's not fun.
Therefore, it was positive work. Now, what about negative work, student 4?
Well, negative work simply occurs when, and that was positive, I'm not being mean. The negative work that we all know occurs when, let's say, you have a displacement like this, and you have a force which is perpendicular to this displacement at a 90-degree angle. So, with this marker, I'm applying to it a force which moves it up, but it's moving horizontally.
Zero work.
No work has been done. I am completely useless.
For example, this is negative work. Force is being applied upwards, but I'm moving it down. Although the force being applied by my hand is upwards, it's moving down.
He's so weak, gravity is stronger than him.
Gravity is so strong.
That's something we'll cover in a later video.
So that's it. Hope you enjoyed energy and work, guys.
Comprendre? Dismissed!